Bismillahirrahmanirrahim. Assalamu alaikum, dear students. Today we are going to discuss about surds and their applications. Before starting this lecture, we must have knowledge about rational numbers and irrational numbers. So we'll discuss first about rational numbers and irrational numbers. So let's define rational number. A number which can be written in the form of p by q, where p and q are integers and q must not be equal to 0, is known as a rational number. For example, 3 by 4, 7 by 9, 11 by 3, 2. 2 is also a rational number because we can write 2 as a 2 by 1 and 1 is not equal to 0. So this satisfies the definition of a rational number. So 2 is a rational number. So 3 is a rational number. Similarly, 4, 5, and these all whole numbers are the rational numbers. Now we'll discuss the numbers which are in the form of a decimal. How we can recognize that numbers are rational numbers or irrational numbers. So if the numbers are terminating, and then we say that that number is a rational number. So for example, that this number is a terminating after a point after 5, this number terminates. So 1 by 2 is equal to 0.5. So this is a rational number. Similarly, 1 by 3 is 0.75. 3 by 4 is 0.75, and this is also a rational number. So because this terminates after 2 decimal points, this number terminated. So here this number is a number which are not terminating, but they are recurring. Recurring means a set of numbers or a single number is repeating again and again. One number can repeat, two numbers can repeat, three numbers can repeat, and if these two numbers or three numbers are repeating again and again, then it means that are recurring numbers. So numbers which are terminating are rational numbers, and those numbers which are not terminating but that are recurring, so that numbers are also rational numbers. So for rational numbers, a number which can be written in the form of p by q, where q is not equal to 0, p and q are integers, are the rational numbers. And the numbers, if the numbers are in decimal form, then that numbers must be terminating. If that number is not terminating but that numbers are recurring, then we say that these numbers are rational numbers. So numbers, if the numbers are terminating and the numbers are recurring, that numbers are the rational numbers. For example, here is 0.66666.6 number is again and again recurring. So we say that this number, so 0.666, this number is a rational number. So irrational numbers, those numbers which cannot be written in the form of p by q, where so we can say that that numbers are irrational numbers. Numbers neither terminating nor recurring, then we say that that numbers are irrational numbers. So here the value of pi is neither terminating nor recurring. So this number is a irrational number. So here you can see that this number is neither terminating and neither you can see that the set of numbers are repeating and again and again. You can say that pi is an irrational number. So again, e, value of e is neither terminating nor recurring, and here you can see that this is not terminating and there are no set of numbers which are occurring again and again. So e is also a irrational numbers. So before defining surds, we define the radical. Consider this nth root of a here. This sign is known as a radical sign. Here a is a radicand, and this is of order n. Here is n. So this is order of the surd, or you can say this is index. So this complete nth root of a is known as radical, and this radical can be surd or cannot be surd. Surd, you can say that the surd is a special case of a radical. So let's define the surd. An irrational radical. It means a radical which must be irrational. It means this radical must be irrational with rational radicand. And the another condition is that this radicand, this a must be a rational number. And this another thing I am adding, that this must be a positive rational radicand. This must be a this radicand must be a positive rational number. So an irrational radical, such a radical which is irrational with a rational radicand, with this radicand, this a must be positive rational, is called a surd. So you can say that surd is a special case of a radical. So there are two conditions for a radical to be a surd. First condition is that this radicand a is rational, means this a must be a positive rational number. And the final and the second condition is that the result is irrational. So this nth root of a must be irrational. That means this radical must be irrational. So when here are some examples of surds. Square root of 3 is it a surd? So let us check. So 3 is radicand. It must be a rational number. Is 3 a rational number? Since 3 can be written as 3 by 1, so 3 is a rational number. And when we take this radical sign, so this whole radical, is this our irrational number? So we know that square root of 3 is an irrational number. So this radical with rational radicand is a surd. Again, example 2, square root of 2 by 5. Again, see, square root of 2 by 5. Square root of 2 by 5 is a radical. Why? Because 2 by 5 is a rational number and this whole radical is a irrational. Similarly, a cube root of 7 is a surd. Fourth root of 10 is also surd. So these are some examples of surds. So let's see some examples, the radicals which are not surds. So square root of pi, since pi is an irrational number, so this is not a surd. Square root of e, since e is an irrational number, so we can say that this radical square root of e is not a surd. Similarly, 2 plus square root of 17, root of 2 plus square root of 17 is not a surd. Why? Because 2 plus square root of 17 is not a rational number. So this is 2 plus square root of 7 is 17. Since 2 plus square root of 17 is a irrational number, so irrational number in radical sign cannot produce a surd. So these are some examples which are not surds. Now we are going to define operations on surds. Addition and subtraction of surds. Similar surds having same order, can be added or subtracted into single, and we are explaining this concept in these example. Here this is square root of 2, this is square root of 2, this is square root of 2, and the order of this square root of this surd is 2. This surd is, when we take square root, it means this is of order 2, and this surd is a special case, and this surd is also known as a quadratic surd. This, the special name of square root of 2 is, this is a surd, and this is a quadratic surd. So square root of 2, square root of 2 plus square root of 2. So we can take square root of 2 as a common. So 1, 1, 1. So we can write this as 3 square root of 2. Here we have 4 square root of 3 minus square root of 3. So we can take square root of 3 common. So we left with 4 minus 1, and 4 minus 1 is 3. So we can write 4 square root of 3 minus square root of 3 is 3 square root of 3. Similarly, here is 6 square root of 5 plus square root of 5 minus 3 square root of 5. So 6 square root of 5 plus 1 square root of 5. We have 7 square root of 5, and here is minus 3 square root of 5. So 7 minus 3 square root of 5. So we have 4 square root of 5. Multiplication and division of surds. Look here. Multiplication and division of surds. We can multiply and divide surds of the same order by making use of following laws of surds. So if two surds are multiplying, these two surds of order n, so we can write this in a single square root and of order n. And similarly, if these surds are dividing, these both surds of order n and dividing, so we can write this in a single root with a by b, and this single root is of order n. So these are two important laws. We will use these laws to solve questions. So multiplication of surds, square root of 2 plus square root of 8. So we can use this first law. So we can write this as in single root 2 multiplied by 8. So 2 multiply 8, we have 16, square root of 16. Similarly, square root of 2 multiply with square root of 18, and we can write this in a single root, and this is 18 2 times 36. So which again, see, square root of 2 multiply square root of 8 is equal to square root of 16 by using first law. And again, square root of 2 multiply square root of 18 is equal to square root of 36. So by using first law, square root of 4 multiply square root of 9. So we can take 2 as outside this. The 4 can be written as 2 square, and 9 can be written as 3 square. So square cancel out with square root, and we left with 2 multiplied by 3. We have 6. So this is 6 can be written as a square root of 36. Similarly, we have square root of 3 multiplied with square root of 5. By using first law, we can write it as a square root of 15. So square root of a multiplied by square root of a, we can write this as in a single root a multiplied by a multiplied by b. So in similar way, we can divide these surds. So let's start the exercise 4.3. Question number 1. Express each of the following surds in the simplest form. So this is square root of 180. So we can find the prime factorization of 180. So 2 9s are 18 and 0 as it is. 2 4s are 8, and here is 10. 2 5s are. So 245 times 90. So 315 times 45, and 3 5 times 15, and 5 ones are 5. So the prime factors are 2 2 3 3 5. So we can pair these two. 2 square, so 3 square and 5. So we can take outsides these 2, 2 and 3. So 2 dot 3, 2 multiplied by 3, 6. So here is, this is 6 square root of 5. So this is the simplest form of the this third square root of 180. 3 square root of 162. So 162 can be factorized here, and you can factorize 162. Here. So the prime factors are 2, 3, 3, 3, 3. So we can pair these. So 2 dot 3 square dot 3 square. So this dot is for the multiplication. So we can take outside this 3 and this 3. So this 3 is 1, 3 is already, so 2, 3 is, we are taken outsides from this radical sign, out of radical sign. So we can write 3 3s are 9 and 9 3s are 27. So 27 square root of 2. So this is the simplest form. Third part, 3 by 4 cube root of 128. So 128 can be written as the prime factors of 128 are 2, 2, 2, 2, 2, 2 and I think we have 7 times 2. So here is, this is cube root, so we can take 3 times 2. So 2 raised to power 3, 2 raised to power 3 dot. So we can take 2 outside, 3 cancel out with this 1 by 3. So we can take outsides from this cube root. So we can write is 3 multiplied with 2 multiplied with 2 and whole divided by 2. So this 3 4s are 12 and 4 3s are 12. So this is 3 cube root of 2. For question number 2, simplify. So this is square root of 18 divided by square root of 3 multiply by square root of 2. So by using the first law of multiplication of the surds, so we can write, by using that first law, we can write these two surds in a single radical sign. So 3 multiplied by 2. So by using the division law for the surds, we can write these two surds in a single radical sign. So 6 3s are 18. So the simplest form of this question is square root of 3. Again, part 2, square root of 21 multiplied by 9 divided by square root of 63. So when we multiply 21 with 9, we have 189 and divided by 63. By using the division property which we discussed earlier, of 63 3 times 189. So the simplest form is square root of 3. Now part 3, fifth root of 243 x raised to power 5 y raised to power 5 and z power 15. So 243, if we find the prime factors of these, so the prime factors of 243 are given here, and so we can write this 3 raised to power 5. So here are the 5 times 3, 1, 2, 3, 4, 5. So 3 raised to power 5, x raised to power 5, y raised to power 10, z raised to power. So this is fifth root, so we can write it as 1 by 5. So this 5 cancel out with this 5 cancel out with this one, and 5 2s are 10 and 5 3s are 15. So the simplest form is 3xy square z cube. Fourth part you have to solve yourself. This is assignment for you. Part 5, square root of 21 multiplied by square root of 7 multiplied by square root of 3. So first we write these last two terms in a single row by using the first law, the law we discussed earlier in that law, the first law for multiplication. So we can write this as 7 multiplied by 3. So that is 21 square. So we can write this is square root of 21. This is square root of 21. So we can write as square root of 21 whole square. So this is equal to 21. So the simplest form is 21. Question number 3. Simplify by combining similar terms. First part square root of 45 minus 3 square root of 20 plus 4 square root of 5. So first we simplify the surds, and after that we can add the similar surds. So 45 we can find the prime factors of 45. These are 3, 3 and 9. Similarly, prime factors of 20 are 2, 2 and 5. So this here is dot is for the multiplication and 5 is addition. So we can take it. So this can be written as 3 square dot 5. Here is 2 square dot 5 and 4 square dot 5. So we can take 3 outside the radical sign. So there is 3 square root of 5 minus. So we can take 2 outside the radical sign. So 2 dot 3 dot 2 and square root of 5 plus 4 square root of 5. So we can simplify as 3 square root of 5, 3 2s are 6. So minus 6 square root of 5 plus 4 square root of 5. So square root of 5 we can take common from these three terms, and we left with 3 minus 6 plus 4. And when we simplify these terms, 3 plus 3 plus 4, 7. 7 minus 6 we have plus 1. So here is 60. So here is square root of 5. So the simplest form. So after simplifying this question, we have square root of 5. Part 2, 4 square root of 12 plus 5 square root of 27 minus 3 square root of 75 plus square root of 300. First, you have to remember that first you have to write these surds in simplest form. So just you have to factorize 12. 12 can be factorized as 2, 2, 3, and 27 can be factorized as the prime factors of 3, 3, 3, and 75 5 multiplied by 5 multiplied by 3, and so 300 can be simplified as 3 multiplied with 100. We have 3 times. And now this is 2 square, this is 3, this is we can write this as this is square root. So we are trying to make the squares. So here is 3 square, 3 as it is. So 5 square cross, and 100 can be written as 10 square. So the values with squares cancel out with the roots with this square root, and so we take outside from the radical side. So 4 multiplied by 2, this 2 we take outside the radical sign. From here we can take 3 outside the radical sign. From here we can take 5 outside from radical sign, and here we can take 10 outside from the radical sign. So we have, so here we can write 4 2 times 8 square root of 3, 5 3 times 15 square root of 3 minus 5, 3 5 times minus 15 square root of 3 and plus 10 square root of 3. This is minus 15 square root of 3 and this is plus square root of 15. So this cancel out with this one. So we left with 8 square root of 3 plus 10 square root of 3. So we can take square root of 3 common from these two terms. So we left with 8 plus 10. So 8 plus 10 is 18. So 18 square root of 3. So part 3 and 4 you have to take as an assignment. So these are very easy. You can solve easily. Question 4. Simplify. 3 plus square root of 3, 3 minus square root of 3. So you know that if we have a square minus b square, we can write at a plus b times a minus b. So here is a plus b and a minus b. So we can write it as a square minus b square. So here is 3 plus square root of 3 and 3 minus square root of 3. So we can write as 3 square minus square root of 3 square. So uh, 3 square is 9, and this root cancel, this square cancel out with this root, and we have left with 3. So 9 minus 3 is equal to 6. Here is part 2, square root of 5 plus square root of 5 whole square. So here we can use the formula a plus b whole square. So square root of 5 is a, square root of b, 3 is b. So a square, square root of 5 square plus square root of 3 square plus 2 square root of 5 square root of 3. A square plus b square plus 2ab. So this cancel out with this one, we have 5. So this cancel out with this square root, we have 3. And so these two are multiplying. So by using the third law for multiplication, we can write these in a single radical sign. So 5 3 times 15. So 5 plus 3 8, and this is plus 2 square root of 15. So 8 plus 2 square root of 15. The simplest one. Here is again square root of 5 plus square root of 3 and square root of 5 minus square root of 3. So this question is similar as we have done. So you can solve this yourself. So this is very easy. Here this is square root of x plus square root of y, square root of x minus square root of y, x plus y, x square plus y square. So first we solve these two terms. So this is a plus b and this is a minus b. So we can simply write as a square minus b square. So when we take b square, so this cancel out with square, cancel out with square root, we have x, and when this square root cancel out with this root, we have y. So we can write is x minus y and x plus y, x square plus y square as it is. So again here we can write x minus y, x plus y as x square minus y square, x square plus y square here as it is. So again this is here, again we can use same formula here. In this time a is x square and b is y square. So a minus b and a plus b, so we can write a square minus b square. So here is x square whole square minus y square whole square. So so 2 multiply with 2, 4, and 2 multiply with 4. So x4 minus y4. So part 4 is assignment for you. So this is exercise 4.3, and in next lecture we will solve exercise 4.3, and we will learn more about the surds. So Allah Hafiz.